let's look at the derivative of tangent. Okay, so we're going to figure this out ourselves. So really, instead of tangent, because I know that tangent could also be called sine of x over cosine of x, that's what we're going to rewrite it as, and we're going to use the quotient rule now. Okay, so our quotient rule says that we always have the bottom, right, times the derivative of the top. The derivative of sine is cosine. I'll just write them up here just in case. So the derivative of sine is cosine, right? And the derivative of cosine is negative sine. Okay, so kind of a pattern. You haven't seen it yet, but anything that's the derivative of anything that starts with a c, any of the trig values, they're always negative. Okay, so keep that in mind. All right, so I have the bottom times the derivative of the top, right? So derivative top is cosine, minus then the top times the derivative of the bottom. The derivative of the bottom is cosine, so this will be times negative sine of x, all over the denominator squared, cosine squared of x. Okay, so on the top, okay, so I'm just going to call this f prime of x equals, I don't like it just floating around. So on the top, this is minus sine times minus sine. So really I could call this, now this is cosine times cosine, so this is cosine squared x, and then this will be plus sine squared x over the cosine squared of x. Here's my f prime of x. Now hopefully you remember the vital trig identity that says that cosine squared plus sine squared is actually equal to 1 over cosine squared of x. And really, 1 over cosine is secant, and so we really have secant squared of x. Really, this is my derivative of tangent. So now we can say that the derivative of tangent of x is secant squared x. Do you have to do that every time? Absolutely not. You can just remember this. Although I might ask you, in a possible test situation to do one of these, okay? Now cotangent is done exactly the same way. It's just that this cosine is on top and sine is on the bottom. You can check that out for yourself, but the derivative of cotangent of x, I'm just going to give you, which is negative cosecant squared of x. I like to do the ones that are positive. I'll leave the other ones for you. I mean, you can try it out if you'd like, okay? So this is another one that we should remember, that the derivative of cotangent is negative cosecant of x. I know cosecant squared of x, so it's kind of like tangent is secant squared, cotangent is negative cosecant squared. So they're kind of the same, but a little bit different. And again, anything that starts with a c, the derivative is negative. Okay, so we're going to do the same thing this time with secant. Okay, so the derivative, or really secant, is really 1 over the cosine of x. Okay, so to do the derivative, I'm going to use, actually, no, I'm not. I'm going to use the quotient rule here, okay? And so that means my bottom, I'm going to have the bottom, which is the cosine of x. I'm going to write this as prime here. Cosine, the bottom is cosine times the derivative of the top, which is 0 in this case, and then minus 1 times the derivative of cosine, which is negative sine, all over the bottom squared, which is cosine of x squared. Okay, so now we have cosine of x times 0, so that's gone. And then I have a negative times a negative, so I'm just left with sine of x over cosine squared of x, which we then break apart. So this is the way we sine times 1 over cosine of x, which then this is tangent of x, and then this is, oh, I'm very sorry here, okay. So I have sine of x from the top, right? I have negative times a negative is positive, gives me sine of x over cosine squared of x, and then I'm just rewriting this as sine over cosine times 1 over cosine. So if I multiply by this back together, I get this, but now I know that sine of x over cosine is tangent, and then this one is secant, okay? We usually write it as secant tangent or tangent secant, it doesn't matter, but the derivative of secant is secant of x, tangent of x. oops, which I wrote up here. Okay, so that's another one. I guess I should have used another piece of paper for that. Okay, so that's the derivative of secant. Now I'm just going to give you the derivative of cosecant. So the derivative of cosecant of x is, again, anything that starts with a c is negative. And this is kind of, so this one is secant, this one is negative cosecant of x, and this one is tangent, this one is cotangent of x. So they're similar, but slightly different. Okay, so there's some similarities there to help you remember them. Okay, so these are our basically 6 big ones we want to remember, right? These two up here, the derivative of sine and cosine, and then you probably don't want to redo them every time, so you probably want to remember that tangent is secant squared, derivative of secant is secant tangent, derivative of cotangent is negative cosecant squared, and then cosecant is negative cosecant of x times cotangent of x. So that's all 6 of our trig identities that we now know the derivatives of. All right, so let's just do, right, some derivatives. So now that we know our trig derivatives, all the same rules apply, right? All the constant multiplier rules work. The product rule is the same. We've already used the quotient rule, but we're going to use it again, okay? So we're just going to do the derivative here. And this is just, I just want to do an example or so of ones that have cosine, and we need a rule, okay? So we have x over cosine of x, which means I need to use the product rule, or I'm sorry, not the product rule, the quotient rule. So the quotient rule goes the bottom, which is cosine of x, times the derivative of the top, which is 1, minus then x, and then times the derivative of cosine, which is negative sine of x, all over cosine squared of x. And so my f prime of x derivative, just to clean it up a little bit, is the cosine of x, and then this will be plus x sine of x over cosine squared of x. And again, just like all the other derivatives that we did, just leave them, it's fine. Unless you're trying to show me that the derivative of secant is secant tangent, then you don't need to simplify for right. I mean, we're just doing derivatives. So let's do one product rule then. So what if we have f of x equals, we'll say, how about cosine of x tan of x? Okay, so this time, again, we need the product. This time we need the product rule. We haven't really used that this time. The product rule says the derivative of one times the other, and then plus the opposite then, the derivative of the other times the first. All right, so I'll just start with the derivative of cosine, which is negative sine, and then tangent is here. That just comes along for the ride, right? It's the derivative of the first, then times nothing happens to the second part. And now we're going to have cosine times the derivative of tangent, which we just learned is secant squared of x. Now, there's all kinds of simplification that I can do in some of these, right? Now, really, there's not a whole lot on this, because if I change tangent into sine over cosine, then I'm just going to get negative sine squared over cosine. But this one I could simplify a little bit, because secant squared is really 1 over cosine. You don't have to do this. I'm just pointing this out, that this could be cosine of x times 1 over cosine squared of x, right? And so this cosine would cancel with one of these, and then this whole side would then just be 1 over cosine, which would just be secant of x. So I could simplify it a little bit by doing that. It's not necessary. I'm just pointing out that it could be. This is an equivalent answer. Okay. All right.